friends, today we are going to learn measurement of angles, degree measure, radian measure. Also, we will see the conversions from degrees to radians and conversion from radians to degree. In the process, we will also develop the relationship between the arc length, angle at the center and radius. First, let us understand what is the meaning of the word trigonometry. Trigonometry is derived from the Greek word trigon and metron, and it means measuring the sides of a triangle. There are many areas such as science of seismology, designing electric circuits, describing the state of an atom, predicting the height of tides in the ocean, analyzing the musical tone, and in many other areas our trigonometry is applicable. In earlier classes, we have already studied the trigonometric ratios of acute angles as the ratio of the sides of right angle triangle. Now, we will generalize the concept of trigonometric ratios to trigonometric functions and we will study their properties. Also, we will study the relationship between L, theta and R, where L is the length of an arc, R is the radius of the circle and theta is the angle subtended by the arc at the center of the circle. Let us understand the concept of an angle. Angle is the measure of rotation of a given ray about its initial point. The original ray is called the initial side and the final position of the ray after rotation is called the terminal side of the angle. The point of rotation is called the vertex. The measure of an angle is an amount of rotation performed to get the terminal side from the initial side. The definition of an angle suggests a unit, which could be one complete revolution from the position of the initial side as given in the figure to the terminal side. There are two systems of measuring the angles. The first one is the degree measure and the second one is the radian system. Let us now study the degree measure. Another name for degree measure is sexagesimal system. Let us see how we are going to measure the angles here. If a rotation from the initial side to the terminal side is 1 upon 3/60th of a revolution, the angle is said to have a measure of 1 degree, which is written as 1 raised to the power of 0. Now, a degree is divided into 60 minutes and a minute is divided into 60 seconds. Just as time, we take the measurements here also. 1/60th of a degree is called a minute and this is written as 1 dash. Also, 1/60th of a minute is called a second. This is written as 1 double dash. So, we have 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. In this system, a right angle is divided into 90 equal parts called degrees. That is, if one right angle is taken, this is going to be equal to 90 degree. Let us see how some of the angles look like. Some of the angles whose measures are 360 degrees, 180 degree, 270 degree, 420 degree minus 30 degree minus 420 degree are shown in the given figures. 360 degree, 180 degree, 270 degree, 420 degree, minus 30 degree which is moving in the clockwise direction, and minus 420 degree, one complete circle, and then another 60 degree in the clockwise direction. Now, let us study the radian system, which is also called the circular system. In this system, angle is measured in radians. A radian is the angle subtended at the center of a circle by an arc, whose length is equal to the radius of the circle. Let us try to understand it. We are going to develop one-to-one correspondence between radians and real numbers. For this, consider a unit circle with the center O. Let A be the point on the circle. Consider OA as the initial side of an angle. Then the length of an arc of the circle will give the radian measure of the angle which the arc will subtend at the center of a circle. Consider the line PAQ which is tangent to the circle at A. Let point A represent the real number 0. AP represents the positive real number and AQ represents the negative real numbers, as we can see in the figure given below. Now, if we rope the line AP in the anti-clockwise direction along the circle and AQ in the clockwise direction, then every real number will correspond to the radian measure and conversely. Thus, radian measures and real numbers can be considered as one and the same. Since a circle subtends at the center an angle whose radian measure is 2 pi and we know that its degree measure is 360 degrees, it follows that 2 pi radians is equal to 360 degree or pi radian is equal to 180 degrees. The above relation enables us to express a radian measure in terms of degree measure, and also we will be able to convert degree measure in terms of radian measures. Here we are going to use the value of pi as 22/7, which is approximation of pi, and with the help of this value we are going to do the conversions. Now, we will see conversion from degree to radian. In example 1, we will convert 30 degree into radian. We know that 360 degree is equal to 2 pi radians. So, 1 degree will be 2 pi upon 360 radian. Therefore, to get 30 degree, we need to multiply 2 pi divided by 360 degrees into 30 degrees. On cancellation, we get 30 degree is equal to pi by 6 radians. Similarly, we can also show that 45 degree is equal to pi by 4 radian, 60 degree is equal to pi by 3 radian, and 90 degree is equal to pi by 2 radian. In example 2, we will convert 40 degree 20 minute into radian. We know that 180 degree is equal to pi radians. First, we will convert 40 degree 20 minute into degrees. Since we know that 20 minute is equal to 1/3 degree, therefore, 40 degree 20 minute is equal to 41 by 3 degree. To convert degrees to radians, we need to multiply this by pi upon 180. So, 41 by 3 degree becomes 121 by 3 into pi upon 180 radian, which on simplification becomes 121 pi upon 540 radian. Now, in third example, we will see how to convert negative of the measurement of angle in degrees to radians. Again, first we will convert minus 37 degree 30 minute into radian. Minus 37 degree 30 minutes is equal to minus 37 and a half degree, which is equal to minus 75 by 2 degree. Now, to convert this into radian, we need to multiply 75 by 2 by pi by 180. On simplification will give minus 5 pi upon 24 radian. In example 4, we will convert 5 degree 37 minute 30 second into radians. Again we will use the concept that 180 degree is equal to pi radian. Now 30 second is equal to 30 upon 60 minute, which is equal to half a minute, because 1 minute is equal to 60 seconds. So, 37 minute 30 second is equal to 37 and a half minute, which is 75 by 2 minutes. To convert minute into degrees, we will multiply by 1 by 60. So, 37 minute 30 second is equal to 75 by 2 into 1 by 60 degree. So, 5 degree 37 minute 30 second is equal to 5 by 8 degree, which is 45 by 8 degrees. Now, to convert this degree into radian, we multiply 45 by 8 by pi by 180, which on simplification gives us pi upon 32 radian. Now, we will see conversions from radians to degree. We know that pi radian is equal to 180 degree. So, 1 radian is equal to 180 upon pi degree. Using this, we will solve the following questions. In example 5, we will convert 2 pi by 15 radian into degree. 2 pi by 15 radian is equal to 2 pi by 15 into 180 upon pi degree, which on simplification gives us 24 degrees. Next, in example 6, we will convert 1 radian into degree. 1 radian is equal to 180 upon pi degree. We will substitute pi by its approximate value 22 by 7. On simplification, this gives us 57 degrees 16 minute approximately. In example 7, we will convert negative of a radian into degree, that is, we will take the example of minus 2. Minus 2 radian is equal to 180 upon pi into minus 2 degree. We replace pi by its value 22 by 7. So, minus 2 radian is equal to minus 114 6 by 11 degree. 6 by 11 is the fractional part of the degree. We will convert this into minutes by multiplying it by 60. So, minus 2 radian is equal to minus 114 degree 32 8 by minute. Again, 8 by 11 is the fractional part, which is to be converted into seconds. So, 8 by 11 will be multiplied by 60. Hence, minus 2 radian can be approximately written as minus 114 degree 32 minute and 44 seconds. In example 8, we will convert 11 by 16 radian into degree. Now, 11 by 16 radian is equal to 180 upon pi multiplied by 11 by 16. After replacing pi as 22 by 7 and on simplification, 11 by 16 radian is equal to 315 divided by 8 degree, which can be written as 39 3 by 8 degree. Now, 3 by 8 is a fractional part which we will convert into minutes. So, 11 by 16 radian is equal to 39 degree 3 by 8 into 60, which is equal to 39 degree 22 minute, and the remaining fractional part 1 by 2 again multiplied by 60 to convert this into seconds. So, 11 by 16 radian is equal to 39 degree 22 minute and 30 seconds. Lastly, we are going to study the relationship between the arc length, angle at the center and radius. More generally, in a circle of radius arc, an arc of length r will subtend an angle of 1 radian. It is well known that equal arcs of a circle subtend equal angle at the center. Since in a circle of radius r, an arc of length r subtends an angle theta whose measure is 1 radian. An arc of length L will subtend an angle whose measure is L divided by r radian. Thus, if in a circle of radius r, an arc of length L subtends an angle theta radian at the center, then we have theta is equal to L upon r or L is equal to r theta. Now, we will discuss some practical problems. Example 9 is one of them. Find in degrees the angle through which a pendulum swings if its length is 50 centimeter and tip describes an arc of length 10 centimeter. Here r the radius is 50 centimeter and s the arc length is 10 centimeter. Therefore, theta, which is defined as L by r radian, is equal to 1 upon 5 radian. We will convert this into degrees by multiplying 1 by 5 into 180 upon pi degrees. So, on simplification, we get 36 upon 22 into 7 degrees, which is 11 5 by 11 degrees. 5 by 11, the fractional part, can be converted into 27 minute 16 seconds. So, theta, which was 1 by 5 radian, is equal to 11 degree 27 minute and 16 seconds. In example 10, we take a circular wire of radius 7.5 centimeter and is bent so as to lie along the circumference of a hoop whose radius is 120 centimeter. We have to find in degrees the angle which is subtended at the center of the hoop. Now, the radius of the circular wire is 7.5 centimeter. Length of the circular wire is 2 pi into 7.5 centimeter, which is equal to 15 pi centimeter. Radius of the hoop is 120 centimeter. Let theta be the angle subtended by the wire at the center of the hoop. Then theta, which is arc upon radius, is equal to 15 pi upon 120 radians. So, theta is equal to pi by 8 into 180 upon pi degrees, which on simplification is 22 degree 30 minute. In example 11, we will see another practical problem. If the angular diameter of the moon be 30 minute, how far from the eye a coin of diameter 2.2 centimeter be kept to hide the moon? Suppose the coin be kept at a distance of r from the eye to hide the moon completely. Let E be the eye of an observer and let AB be the diameter of the coin. Then the arc AB is approximately equal to the diameter AB, which is 2.2 centimeters. Now, the angle theta is 30 minutes, which is equal to 30 upon 60 degree. To convert this into radians, we multiply 30 by 60, which is equal to 1 by 2 by pi upon 180 radians. So, theta on simplification is pi upon 360 radian. Theta is arc upon radius, therefore, pi upon 360 is equal to 2.2 divided by r. So, r is equal to 2.2 into 360 into 7 divided by 22, which is 252 centimeters. After completing this module, students will be able to understand the concept of degrees, radian, relationship between degrees and radians, and conversion from degree to radian and radian to degree. They will also understand and will be able to apply the concept theta is equal to L upon r or L is equal to r theta.